Hi, this is Muad from JB Academy. I'm again with you in another new video. In today's video, we will discuss very important lesson, which is lesson 8.2, Greatest Common Factor GCF. How to find the greatest common factor for two or more than two numbers using different strategies. So our objective will be today find GCF using many strategies. Of course, we can use two main strategies. Of course, you can find it mentally, but we can use list factors and we can use what we call PF or prime factorization. The second point, we want to use the GCF and distributive property to find the sum of two numbers. So we need to apply the GCF. What is the GCF? What is the greatest common factor? We already know what are the factors of any number. But what is GCF? What is the greatest common factor? Is the greatest number that's a factor of two or more than two numbers. It is the greatest number that is a factor. It is a factor for these two numbers or more than two numbers. Here we have some examples. We can find this mentally. Sometimes if the numbers are easy, we can say what is the common factor or the greatest common factor of, let me say, 10 and 15. 10 and 15. I can think about the factors of 10 as 1, 2, 5, 10. And I can think about the factors of 15 as 1, 3, 5, and 15. So the first thing I think about it is 5. 5 is the factor for these two, it's common factor for these two numbers, which is 10 and 15. And it's the greatest factor because they have just one common factor, it's 5. And they have one, the one is common factor. But the common factor, which is the greatest common factor, is 5. Here we start. Of course, we will focus on two ways. The listing the factors, then we choose the common, then we choose the greatest common factor. And the other way, which is famous way, which is the formal way, I think, it's the prime factorization. Now, find the GCF or the greatest common factor using different strategies. It's up to you if you can find it mentally. For example, the first two numbers, 12 and 16. They are both even numbers. Do they have other common factors other than 2? I'm thinking now as mentally. 4, 6. 6 is a factor of 12, but is it a factor of 16? 8. 8 is a factor of 16, but it's not a factor of 12. So 12 itself, let me try 12 itself. 12 is a factor for itself, but it's not a factor of 16. So I think it is 4. I think it's 4. But let me use list factors because they are easy numbers. Now I write the factors of 12, which is 1, 2, 3, 4, 6, and 12. 1 multiplied 12, 12, 2 times 6, 12, 3 times 4, 12. Now 16, 1 and 16, this is the first thing we write. And it's even number, so 2 and 8. What else? 4 and itself. 4 multiplied 4 equals 16. Now, what are the common factors? 1, 2, and 4. We have three common factors, 1, 2, and 4. But what is the greatest common factor? It's 4. It is 4. So the answer is 4. But what's the disadvantage in this way? Sometimes students forget some factors of a number. So in this case, they will not get accurate answer. So we can use the prime factorization way. How? Let me see. Let's see. 35 and 14. So I will use the prime factorization for t 35. 35, as you remember in the previous video, we have explained how to find the prime factorization of a number. I still have these prime numbers, they can help me. Now 35 can be written as, the first thing I think about it, it's 5 times 7. Yes? Now I continue, but look, 5 and 7, both prime numbers, so I should stop. So I write 35 equals 5 multiply 7. Now 14, it's even number, so it's a good way to start by 2. 2 and 7. Also, both are prime numbers, so I stop. So 14 equals 2 multiply 7. Now the GCF, how I find the GCF? From the prime factorization. The GCF, I multiply the common prime factors. I look, 35 and 14, do they have common prime factors? Yes, they have 7. They have the 7. Multiply. Do they have others? Do they have another or other common prime factors? No. So I don't multiply 7 by anything. So the GCF for them is 7. So after you find the prime factorization of two numbers, you multiply the common prime factors. Let me show you how to find the GCF for 12 and 16 using prime factorization. 12, 16. 12 is 2 and I will go, I'm going back to the first example, but I'm using the GCF. 2 and 6. 6 is 2 and 3. Now 16 is 4 times 4. 4 can be written as 2, 2, and this 4 as 2, 2. Now, for 12, I get equals 2 times 2 times 3. 2 times 2 times 3. And 16 equals 2 multiply 2 multiply 2 multiply 2. Now the GCF equals, I multiply the common prime factors. Do they have common prime factors? Yes, they have the 2. Do they have another thing? Yes, they have another 2 common. 2 times 2, 3 is not common, equals 4. Here, in listing the factors, I get 4 also. So these two ways we can find the prime, the GCF. Now, another application for the GCF, use the GCF, the greatest common factor, and distributive property to find 15 plus 36. I mentioned in the beginning, we need to use the GCF and distributive property to find the sum of two numbers. Now, how I find the sum of these two numbers? I can find it mentally, or I can add them using the formal way, but I want to use the GCF and distributive property. What's the first thing I need to find? The GCF for 15 and 36, using prime factorization or using listing the factors. If you think about 15 and 36, you can find, look, 15, 36. 15 is 5 times 3. 36 is 6 times 6. 2, 3, 2, 3. So the GCF, I multiply the common. 3 is common, so I multiply 3. By what? Do we have other common? No, 5 is not common, and 2 is not common. So the GCF is 3. Now, the second point, the second step, I write each one of them as a product of two factors, and the GCF is one factor of them. So I write 15 as 3 multiply 5 plus 36, I write as 3 multiply what? 3 multiply 12. Now what I did, I found the GCF, which is 3. Then I write each number of them as a product of the GCF and another number. So now I use distributive property. So the common factor is 3. So I put 3 brackets 5 plus 12 equals 3 multiply 17 equals 51. Now this is very important point, how I use the GCF and distributive property. First I find the GCF for the two numbers, then I write each number as a product of the GCF and another factor. Then I use the distributive property here. I put 3 outside and I add 5 plus 12. First I add 5 plus 12, then multiply them by 3, which is the GCF, equals 51. By this, we come to the end of this important lesson for finding GCF. Thank you very much.